Good morning students. I am going to take the topic classification of signals and systems. So what is the signal means? Signal which is nothing but a physical quantity that contains physical information. For example, music, speech, audio and video are the signals. So signal is nothing but a physical quantity that varies with one or more independent variables. So what will be the classification of signals means? It is divided into continuous time signal and discrete time signal. Continuous time signal is the signal which have continuous values for every specific intervals of time. So what is meant by discrete time signal means the values of the signal will be only at the discrete points. It is not mentioned or occur during all the intervals or every time of the signal. So these are the classification of signal. Again it is divided into analog signal and digital signal. Analog signals are continuous in both amplitude and time. So digital signals are the signals which have only two values of amplitude, that is zeros and ones. Zeros and ones are the two values of the discrete digital time signals. Next, classification of signals. This is the example for continuous time signal and digital time signal. So digital time signal is to have only two values, either zeros or ones. This is the example for your discrete time signal. So n are the values of the x-axis and x of n is the signal which are discrete in nature. Look into this signal, you have values only at the 1, 2, 3 and 4, not in between the values. The signal won't exist in between the values of 1 and 2. So from this plot you have to find the time and the amplitude of the corresponding signal. This is an example for discrete time signal. It is represented by x of n. N is the value along x-axis and x of n is value along y-axis. So in this, for the value of 1, the corresponding amplitude will be 2. For the value of 2, the corresponding amplitude value will be 3. For x of 4, for n equal to 4, your x of 4 value will be 6. This is the graphical representation of the discrete time signal. These are the signal types. So analog continuous time signal, analog which is discrete in time, third one is digital continuous time signal, fourth one is digital discrete time signal. So classifications of signals: continuous time signal and discrete time signal, even and odd signal, periodic and non-periodic signal, deterministic and random signals, energy and power signals. We have already seen continuous time domain and discrete domain signals. Then second we will see even signal and odd signal. What is even signal means? A signal that exhibits symmetric property with respect to t. T is equal to 0 which satisfies the condition x of t is equal to x of minus t. If this condition is satisfied means it is said to be even signal. Next is odd signal, which is just opposite of even signal. A signal that exhibits antisymmetric property with respect to t is equal to 0 is called as odd signal, which satisfies the condition x of t is equal to minus x of minus t. Next we will see a periodic signal and aperiodic signal. What is periodic signal means? The signal which repeats at regular time intervals, which is said to be periodic signal. Aperiodic signal is the signal which does not occur or repeats at the regular intervals. It is called as aperiodic signal. So this is the example of your periodic and non-periodic signal. In periodic signal, every time limit the signal repeats at regular intervals. So next topic is energy and power signal. The signal which has finite energy and zero average power, which is called as energy signal. The non-periodic signals are exponential signals which have only constant energy. So non-periodic signals are energy signals if it satisfies the following equation: 0 less than or equal less than E less than infinity and P is equal to 0. Power signal, the signal which has finite average of power and infinite energy is called power signal. The periodic signals like sinusoidal exponential signals will have constant power and so periodic signals are power signals. The expression for periodic signal is 0 less than p less than infinity and e equal to infinity. Deterministic and random signal. What is meant by deterministic signal means the signal which comes under or satisfy any mathematical equations are called as deterministic signal. So incidence values can be predicted in the deterministic signal. Example is sinusoidal signal. Second point is random signal. What is meant by random signal is, and there will be no certain points over the signal. The certainty of the signal cannot be determined. So such a signal is called as random signal or non-deterministic signal. So non-deterministic signal is also called, we can represent as a noise signal. It is also called as a noise signal. So example of sinusoidal signal is given, and this is a random signal which contains no information or uncertainty in the time intervals. These are the basic continuous time elementary signals. First one is unit step signal, which is given by u of t is equal to 1 only for t greater than or equal to c. In this plot you can see only at t value 0 and greater than 1 the value occurs at the u of t. Other values will be 0. This signal, this type of signal is called as unit step signal which satisfies the following condition, that is only t is equal to 0 or greater than 0 the value will exist. Second is ramp signal. Ramp signal is nothing but r, it is represented by r of t is equal to t only when t greater than or equal to 0. If it is not satisfy this condition means is equal to 0 for t less than 0. Such a type of signal is called as unit ramp signal. Next is unit pulse signal. The expression for unit pulse signal is pi of t is equal to 1 only when the time interval is minus 1 by 2 to 1 by 2 0 elsewhere. If the signal satisfies this condition, it is called as unit pulse signal. Next is impulse signal. So impulse signal is only when t is equal to 0 it exists, otherwise it won't exist. So can you give an example for unit impulse signal? Thunder. So it is an example for unit impulse signal. Then examples of signals. Examples of signals we can use speed signal, audio signal, image signal, etc. So I have taken the example from biomedical signals. These are the kind of signals which are used in biomedical term. ENG, EMG, ECG, EEG and EEG, PCG, ERG, EOG. These are these commonly used biomedical signals which gives the information about the specific organ of the human body or whatever analyzed, it gives the information about the used signals. So for example, if you take EMG signal means it will give the signal value will give the electrical activity of the muscle cells. Electrical activity of the muscle cells is calculated as signals. So these are the commonly used biomedical signals. So next one is acoustic biosignals. Any idea regarding acoustic biosignals? Yes, right. Subset of mechanical signals that describe the aquatic sound produced by the body, that is vibrations and motions of the living organisms are calculated and it is calculated and given as acoustic biosignals. These are the various bioacoustic signals, we can find it in the real time world. First one is cardiac sounds, which it is called as phonocardiography. Second one snoring, so which is used to find the disease obstructive sleep apnea detection, which gives the vibrations of the signal during snoring. Third one is swallowing. So whatever signals come as values will give the how much time taken to inhale or swallow the given food. Fourth one is respiratory sounds. Fifth one is crackles of joint and muscles. Why this acoustic biosignals are used means it is used to monitor the patient who are under certain conditions, some medical issues. These acoustic biosignals are used to calculate the signals values which are come from the patients. Next, signal processing. What is meant by signal processing? Doing some manipulations, calculation, interpretation, some analysis which are done on the signals, which is called as signal processing. Why we go for signal processing means to have exact information from the system. So we go for signal processing. Next, mathematical calculations used to analyze signals. So everywhere there is mathematics involved to calculate signals. So these are the common terms which are used to analyze the signals: Fourier transform, Z transform and Laplace transform. Fourier transform, Laplace transform is applicable for both continuous and discrete. Z transform is made for your discrete time signal analysis. These are the commonly used tools which are used to analyze signals. System, any system which gets information and do some calculation and given as output is called as a system. It is divided into linear time invariant system and discrete time invariant system. Look at this expression, y of t is equal to function of x of t. Here y of t is the system and the function of x of t is x of t is input and f is mathematical calculations used and gotten as output. Y of t is output, function is doing some mathematical calculation, x of t is doing on what signal. Y of t is equal to f of x of t. So continuous time system and non-discrete time systems. For example, you can continuous system we calculate and do manipulations only on continuous time signals. For example, audio, video amplifiers, power supplies, etc. are continuous time systems. For discrete time system, we go for examples which will operate only on discrete time values. So example, microprocessor, semiconductor memories, shift registers are example for discrete time signals. So after this we will calculate one problem and plot the signal.